Hi, welcome back to Find, Solve, Explain. Here we have BMO2 2020 question 1. This is a nice question that involves a small amount of modular arithmetic, but other than that it's fairly simple. A sequence A1, A2, A3 has A1 greater than 2 and satisfies the relation an plus 1 is equal to an times an minus 1 divided by 2 for all positive integers n. For which values of a1 are all the terms in the sequence odd integers? I started this problem out by trying small examples. In particular, 3 is the smallest positive integer, greater than 2. It's fairly simple, because 3 times 3 minus 1, which is 2, divided by 2 is equal to 3. So we already have our first solution. However, as we try larger examples, it seems more and more difficult. This is because we always end up getting an even integer at certain points in the sequence. One of the things you may notice is that there's a trend in the values of an minus 1. Whenever an minus 1 is divisible by 4, it will clearly break. And whenever a1 minus 1 is clearly divisible by 4, it will break. And whether a2 minus 1 is divisible by 4, it will also clearly break. And this follows for any of them. If any of them are divisible by 4, the sequence will come to an end, and we will not have infinite odd integers. So, if this value is divisible by 4, that means that the next one, so ak, has to be congruent to 1 mod 4, where k is some value somewhere along the sequence where it breaks, or right before it breaks, rather. So, if we have the theory that 3 is the only one, this means every other value, say ak is congruent to minus 1 mod 2 to the n, doesn't work. Now we will look at, a1. Now we will look at the value of a1 congruent to minus 1 mod 2 to the n plus 1. We will look at this equation. We take a1 times 2 to the n plus 1 mod n, where it's minus 2, all divided by 2. Or wait, we can simplify this, sorry. If we look at the entire equation mod 2 to the n plus 1, this will give us minus 1 times by minus 2 over 2, which is congruent to 1 mod 2 to the n plus 1. The key here is that because of this division by 2, what this really is mod 2 to the n, and not 2 to the n plus 1. This is why 3 is also the only value that works, as 3, which is minus 1 mod 4, times by 2, which is minus 2 mod 2, which is minus 2 mod 4, divided by 2 is congruent to 1 mod 2, which isn't against our rules, unlike all the rest. So, therefore, because the next one will be congruent to 1 mod 2 to the n, and 2 to the n is divisible by 4, we're done.